This session is for OCR FP2. The topic that we're looking at is graphs of rational functions, and we're doing question 3 from January 2011. So let's start by reading through the question. So we're given a function f, which is defined by f of x equals 5ax over x squared plus a squared for all real values of x and a is greater than 0. In part 1 it says, for the curve y equals f of x, write down the equation of the asymptote and find the range of values that y can take. And then in part 2 it says, for the curve with equation y squared equals f of x, write down a, the equation of the line of symmetry, and b, the maximum and the minimum values of y, and in c, the set of values of x for which the curve is defined. So if we start by looking at part 1 and part 1a, so in a then we should see that of course the equation of the asymptote is going to be y equals 0. So remember, as x tends to infinity, f of x is going to tend to 0. So y equals 0 is an axis of symmetry. And then in part b it says, find the range of values that y can take. Now there are different ways of doing that, and one could do it by differentiation, but I think that the easiest way to do it is to take our function and write it as a quadratic in x squared. So we'll have y lots of x squared plus a squared equals 5ax, and if we rearrange that we'll get yx squared minus 5ax minus a squared y plus a squared y equals 0. Now, for the quadratic needs to have real solutions for our graph to exist. So real solutions for this quadratic are going to be when b squared minus 4ac is equal to 0. So for real values of x, b squared minus 4ac must be greater than or equal to 0. So that implies that 25a squared minus 4a squared y squared is greater than or equal to 0. Now we know that a is greater than 0, so we can divide through, and that means that 25 minus 4y squared is greater than or equal to 0, leading to the solution, which is that y must be between minus 5 over 2 and plus 5 over 2. And again, if necessary, just do a little sketch of this quadratic. It is of course a maximum, so it's between these two values. So in terms of marks for that question, the 5 marks for part 1, well, there was just 1 mark here, a statement mark for writing down the equation of the asymptote. There was a method mark for expressing our function as a quadratic in x, and also another one for seeing that real values would exist when b squared minus 4ac is greater than 0, and an accuracy mark for getting our inequality, and a further accuracy mark for getting the correct range of values. So that now is part 1. Let's have a look at part 2. So in part 2 now we're dealing with the graph y squared equals f of x, and in part A we're just asked to write down the equation of the line of symmetry. So the line of symmetry is going to be y equals 0, or the x-axis, whichever you prefer. So remember that your y squared equals f of x graphs are always symmetrical about the x-axis. In part B, now we know that y had to be less than or equal to 5 over 2, which means that the maximum value is going to be the positive value of that, which is the square root of that, I should say the positive square root, and the minimum value is going to be the negative square root. So again, you were just being asked to write down these values, and then in part C, again, the curve will only, notice that if you remember what the equation of the function was, it was a 5ax over x squared plus a squared. That was our function, and we were told that a was greater than naught, so this function, of course, y squared equals f of x, will only be defined for x greater than or equal to naught. So in terms of marks, there's 4 marks in total for this particular part, but they were all just statement marks. So a statement mark for each part. So 9 marks in total for question 3. So don't forget that if you want to watch further revision videos, then you can do so by going to the Further Maths Support Programme website and following the link.